Okay, in this presentation we're going to look at the central limit theorem, summations of random variables, and the normal distribution. Okay, so suppose that the sums assured under policies of a certain type are modeled by a distribution. You notice that we're not told what distribution. We're not told anything about it. Normal, exponential, nothing. But we're told here that it has a mean of $8,000 and a standard deviation of $3,000. So consider a group of 100 independent policies, and essentially what we're asked for is to calculate the approximate probability. That's a sort of hint there to use an approximation. Essentially that sort of flags us towards the central limit theorem, so that's a bit of a clue that the total sum, the total sum of 100 policies under this group of policies exceeds 845,000. Okay, so what we have here is a sum of 100 policies. So that's the key thing here. Okay, so the expected, so under the central limit theorem, we expect the sum to be normally distributed, okay, of the 100 observations. Okay, so this is the idea of the central limit theorem, that the summations, assuming the sample size is sufficiently large, in this case we do have that, okay. Actually, that's worth remarking. N is very large. N is large enough. N is large, actually. N is greater than 30. That the S is normally distributed with a mean of 100 times 8. Let's just work in terms of thousands. So mu is 8 and sigma is 3. Okay, just use those terms there. And the variance is sigma squared for S, mu of S, is 100 times 9, which is 3 squared. Okay, so that's essentially using the central limit theorem, making it state that assumption there. Now, essentially what we have here is a normal distribution question after that. Okay, so just as a quick reminder about the standardization formula, okay, so the z-score. So essentially what we do there is for some value x, we subtract the mean and divide by the standard deviation to find the z-score. Okay. So the total sum assured, S, is normally distributed. Sorry, I've actually just went past that already. So this is where we're at, okay, and approximately by the central limit theorem. Okay, just actually I should have made a remark there that N is large. I should have actually wrote that in there to qualify it. Okay, so essentially what we're asked here is probability of S being greater than 845. Okay, that's in thousands, so 845, where mu is 800 and the standard deviation is 30. Okay, mu of S is 30. So probability of S is greater than 845. This is it. So essentially using the z-score formula here, z-score, 845 minus 800, which is x minus mu, divided by the standard deviation, in this case is 30. So we have 845 minus 800 all over 30. That gives us 1.50. Just actually state that z is the standard normal random variable. Okay, just little something like that, just to sort of say where it comes from. Okay, so probability of z greater than 1.5, using statistical tables, we should get that an answer of 0.067. Okay, and that is it. Okay, it's not a particularly long question here. So the key thing here is actually just sort of setting it up as a random variable. Okay, invoking the central limit theorem and setting it up as a random variable. And then after that, it's a standard normal distribution question. All right, we'll leave it there.